Hi, this is Sung, your online maths mentor, and we're well and truly into the Extension 1 course, and this is the topic, or this is a new topic that I would like to introduce you to, called circle geometry. So as you can well imagine, it's got to do with geometry, which is an extension of the geometry course that we did in the 2-unit course, but it's the Extension 1 component which actually deals specifically with, you guessed it, circles, because that's what it's called, circle geometry. So in this episode, basically my aim is to kind of go through some definitions, and a lot of this will be revision, no doubt, but what I basically want to do is go through the parts of a circle. So can you name the parts of this circle? So this circle over here. So let me just grab a pen, and I'll use a red pen just to help us out. So the first thing we need to do is work out, a circle, right? Circle is this whole thing here, all right? And what defines a circle is basically, it's the locus of a moving point that moves equidistant from another point. So basically, what is unique about a circle, what makes a circle is that from some center, you have a set radius or a set distance that traces out the path of the circle, which is what makes it so. So that basically is 1, okay? A circle is that basic shape there, all right? Number 2 is the center. Obviously the center of the circle is there, so that's 2. I'm going to name that 2. 3 is your diameter. Now, some people confuse diameter with radius. Now, what diameter is basically a straight line that passes from one end of the circle all the way through to the other end of the circle, but it must pass through the center, right? And what you'll find is that a diameter is the longest chord that can be made in a circle, right? So in other words, a diameter is the longest chord. So a chord, right, which is what I'm going to go through here, right, which is number 8 chord, is that, which is basically joining one end of the circle to the other end of the circle. So that's chord. So I'm kind of going to jump around here a little bit, but a diameter is the longest chord that you can make because it passes through the center. And so that is 3. On the other hand, a radius, right, now you should all know this, is basically the straight line distance, or the straight line from the center all the way to the edge, which is called the circumference, right? So from there to there is your radius. That's number 4, okay? Now, how many radiuses make up a diameter, okay? We need to know this. Basically, you've got this radius here and you've got this radius here. So in a diameter, you've actually got 2 lots of your radii, okay? And the plural is radii. Now, the other thing that I haven't written on the board is circumference, like I was mentioning before. So I'm gonna write that out on the board. So the circumference is basically the outside length, or the outside perimeter of the circle, all right? So circumference. All right, hopefully you can read that. So what have we done? We've done circle, we've done center, we've done diameter, radius, and we've done chord. Now, let me just go through the next one, which is an arc. Now, an arc is just some part of the circumference, right? So you might go from, say, that point there to that point there, and it's the distance around that, all right? So can you see what I'm doing? That distance there is called your arc, right? Now, an arc can be any length, just like a piece of string can be any length. How long is your arc? Well, it just depends on how it's defined on the circle, right? But basically, it's just any portion of the circumference. Any portion of the circumference is called your arc. Now, there's 2 other words that I want you to know. The first one is called sector, and the second one is called segment. Now, a sector is this. It's basically a slice of your circle, right? That actually starts from the center, all right? So basically, if you were to cut up a piece of pie or a slice of pizza, that would give you a sector, right? So so a sector would be something like this. So it's 6, right? All right. Do you see that? That's called your sector. Whereas a segment, right, is what you get if you cut up a cake in a very sloppy way. So if you cut up a cake in a sloppy way, you would end up cutting through the cake using a cord, right? So see that? And basically what you're left over with is called a segment. So 7 is segment. Now, how do you remember the difference between a sector and a segment? Well, the way I like to remember it is you look at the last letter of the word sector. It ends with the letter R, right? So R for radius or radii. When you've got 2 radii cutting up a circle, you've got yourself a sector. Whereas, whereas a segment is basically, cut up using a cord, right? Now, there are 2 types of segment, all right? There is the major segment and the minor segment. So listen, if you cut up a circle using a cord, you end up with 2 pieces, right? You end up with a big piece and a little piece. So let's have a guess, right? We're not, using our powers of, guessing, right? What would the big piece be more likely to be called? The major segment or the minor segment? Yeah, right? Without trying to insult your intelligence, basically the big bit is called your major segment. Your little bit is called your minor segment, right? So the bit that I've colored in here is your minor segment. Everything else above is your major segment. Does that make sense? Cool. Now, the last thing that I want to go through before we go through some of this stuff, which is a little bit more detailed, is what a tangent is, okay? So let me go through what a tangent is. A tangent is a very specific type of line that touches the circle at one point. Only at one point. So it touches the circumference of the circle at one point. What you will find, right, is that at that point of contact, right, the radius from the point of contact to the center of the circle, right, will be perpendicular to, in other words, 90 degrees to the tangent. And we'll go through that a little bit later, okay? But that should be, it might also make common sense, right? So the tangent is a line that touches the circumference at one point and just kind of keeps continuing through, okay? So that's basically what your tangent is. Now, I want to go through some of this stuff, all right? I'm not going to refer so much to the traditional circle that I've got here to do some of this stuff. I'm going to basically just use this space here, all right? So the first thing that I want to go through is concyclic points, all right? What are concyclic points? That's a very good question, and I'm glad you asked. So concyclic points, now you can put a whole bunch of points on a page any which way you want, right? So you can have a point there, 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 right? What makes concyclic points concyclic is that you are able to draw a circle that passes through those points. Now, there is a theorem that says any 3 points on a page are going to be concyclic. Any 3 points on a page are concyclic, whether you like it or not, okay? See if you can work out why and how that might be the case. If you want to jump into it and come up with a proof, please do so. I'd be interested to see what sort of proof you come up with and how you go about doing it. It's not impossible. It is fairly standard, although it might stretch your minds. But basically, concyclic points are points through which you can draw a circle. So let me give you an example. If you've got 4 points, right, those 4 points, so let's call it A, B, C, and D, and excuse my crude drawing here, but if we are able to draw a circle that passes through all those 4 points, then we can say A, B, C, and D are concyclic, right? Not only are those 4 points concyclic, but if we join up the line, okay, now just excuse my crude drawing, right? But if we join up the dots and form a polygon, let's join up A and D, for example. Let's also join up D and C, C and B, B and C, and A and B, yeah? So if we join all of that up, what are we left with? We're left with a quadrilateral inside a circle, right? Where the vertices of the quadrilateral, or the corners of the quadrilateral, actually sit on the circumference of the circle. Yes? All right. What you have there is what we call a cyclic quadrilateral, because the 4 points that make up the quadrilateral are concyclic. Yeah? And we will learn a theorem, without jumping the gun here, we'll learn a theorem that has to do with cyclic quadrilaterals, which basically says that the opposite angles of a cyclic quadrilateral, so this angle and this angle, are going to be supplementary. In other words, add up to 180 degrees. And you'll find that the same thing happens between these two angles here, because they're opposite to each other on the cyclic quad. Okay? Good. The next thing I want to do is go through, so we're going through this at a lightning pace, but the next thing that I want to go through is concentric circles. Concentric circles, co or co meaning same, centric meaning center. Concentric circles are two circles that share the same center, okay? So for example, you might have a circle that looks like this, that has a center there, and you might have another circle that looks like this, which shares the same center. You can actually say that this circle here and this circle here are concentric circles, okay? Concentric circles. Now, the other thing that you might have come across is the word, all right, is the donut shape, right? The donut shape here, right? And there is a special word for it, okay? There is a special word for the donut shape, right? It's called a, not a donut, it's called a annulus. So it's called an annulus, okay? And what makes an annulus is that it's a donut shape, right? So it's a circle with the hole punched out through the middle of it, but what needs to happen for an annulus to be an annulus is that the two circles, the inside circle and the outside circle, have to be concentric circles. Good. All right, now, the last thing that I really want to go through is some of the terminology that we're going to be dealing with as we go through this, this unit of work. Now, this unit of work will largely revolve around me giving you theorems and axioms, all right, mainly theorems, to do with circles so that you can go away and understand them, and then the proofs that may or may not follow to set up the theorems, okay? So that's basically what this chapter will entail, and then it'll be a matter of you being able to use those theorems and recognize those theorems to build deductive proofs around problems involving circle geometry, okay? So, let's have a look at this. An angle subtended by an arc or chord at the center or at the circumference. Okay, now let me go through this. So if you have a circle, all right, as ugly as that might look, and you have a center there, all right, an angle subtended by an arc or a chord at the center or circumference looks like this. So if you were to have a chord, can you also see that from this point to this point, you've either got the chord or you've got the arc, yes? All right, an angle subtended by the arc or the chord at the center is an angle where you join the point from the center to each of the points at the end of that chord, all right, or that arc. So this angle there, right, is your angle subtended by the arc or the chord. This is your arc, this is your chord at the center. Yeah? What do you think an angle subtended by an arc or a chord at the circumference would be? Well, it would be any other point. So we could say, for example, this point here, all right? And if we were to draw the angle subtended, that angle there, all right, would be your angle subtended by your chord or arc at the circumference. Yeah? And you can have that same angle being over here, or over here, or over there, right? So joining that up, okay, or that up. Does that make sense? All right. Now, there will be animations that follow this. So if this looks too messy for you, then just follow the animations. But what I will say at this point is that when you've got a common chord, all right, or a common arc, right, and you're subtending angles at the circumference, you will notice, all right, and I will prove later on in a different episode, that these angles here are all going to be equal. not only are all these angles going to be equal, but you will find that the angle at the center will be double the angles at the circumference for any common chord or any common arc. Okay, so yeah, that's number 13. We've kind of covered that. And the last thing that I want to say is that we also need to talk about the reverse, which is an arc or a chord subtended by an angle, right? Which basically is the reverse thing. So if you've got an angle, right, from the center that kind of branches out, then whatever 2 points are left, whatever other 2 points that it cuts the circle or meets the circle, and you draw an arc or a chord there, that will be your arc or a chord subtended by an angle, right? And there will be animations to follow there, right? But that's basically what I wanted to do to cover with you some of the definitions that you might need to know for circle geometry. If you're not familiar with them, and I suspect most of you will be familiar with them, but if you're not, and you need to go back and review this, please by all means do so. You will need to be familiar with it, and there is no shame in not knowing them at this stage, although yeah, I would like at the end of this episode for you to go away and revise it to the point where you are able to name offhand all of those features on a circle. All right, thank you very much for watching. In the next episode, I'll launch straight into doing some of the theorems that are associated with circle geometry that will help you with your deductive proofs. Thank you again. See you later.